At this point in time, we've filled out most of the unit circle here. There's some information on this particular circle we haven't gotten to yet, but the stuff we have talked about are the special reference angles. All the angles that we're going to talk about on the unit circle either have a reference angle of 30, 60, or 45, or they're an angle that lie on an axis. We also talked about the ordered pairs where each of those angles hits the unit circle, and we now know that the first value is the cosine of that angle, and the second value is the sine of that angle. We didn't really talk much about tangent. One of the definitions that we were given for tangent was y over x. When we were given this circle, where this was x comma y, and then we found out that we could call this side of the triangle x, this side y, and then the hypotenuse is r for radius. And we had a different set of definitions that really was the same thing as SOHCAHTOA. So for the angles from 0 to 90, and the only reason I'm doing 0 to 90 is because I've already mentioned that the rest of the angles in quadrants 2, 3, and 4 will have the same answers, but they will be either positive or negative depending on what quadrant they're in. So for the tangent of 0, if you do y over r, the ordered pair would give you 0 over 1, which is 0. At 30 degrees, I've already messed this up. I'm going to get rid of these two real fast, rewrite them. At 30 degrees, you would have y over r. What happens is when you divide a fraction by a fraction, you take the numerator and you multiply it by the reciprocal of the denominator. And you end up left with this. So this is 1 over the square root of 3, which is square root of 3 over 3. At 45 degrees, both coordinates are the same. So when you do y over r, anything divided by itself is 1. At 60 degrees, y is square root of 3 over 2, and x is 1/2. So if I apply this method of simplifying the fractions, I'm going to get square root of 3 over 1. And at 90 degrees, when you do y over x, you get 1 over 0. And since we can't divide by 0, we find out that the tangent is undefined. Remember that the cotangent is just the reciprocal of each of these fractions. What if we want to find the measure of a missing angle in a right triangle? Up till now, we were just finding missing sides using trigonometry, but we can also use the trigonometric ratios to find missing angles. So let's say I gave you the sine of theta is equal to 1/2. You should have done this in geometry when you learned sine, cosine, and tangent. To find a missing angle, in order to solve for theta, you need to do its inverse operation to the other side. Well, the inverse operation of sine is called inverse sine. This is pronounced inverse sine, not sine to the negative first power. It's not the same as raising something to the negative first power, but it is our convention for writing inverse sine. If you look at the sine, cosine, and tangent functions on your calculator, you'll see in the second function above it is inverse sine, inverse cosine, and inverse tangent. This book also introduces arcsine. This is an outdated concept for inverse sine. It means the same thing. If you plug into your calculator the inverse sine of 1/2, the calculator will spit out the answer 30, and that's 30 degrees because the sine of 30 degrees is 1/2. Let's go and talk about some examples of using our inverse trig functions. In example 1, I want to solve each equation. So in order to solve tangent x is equal to 1, we would start by doing x is the inverse tangent of 1. And when you plug this into your calculator, it spits out the answer 45. But we're going to come back to this in a minute because there actually is another answer that's going to give you positive 1. And then for sine x is equal to negative 1/2, you do the inverse sine of negative 1/2. And the calculator's going to spit out negative 30. All right, now let's go back and talk about this. So there is this acronym that I've mentioned before but didn't do much with for determining what quadrants your trig functions will be positive. And the acronym is All Students Take Calculus. And it starts in Quadrant 1, goes to Quadrant 4. The A means all of the trig functions are positive in Quadrant 1. The S in Quadrant 2 means that sine is positive, but everything else is negative. Quadrant 3 has a T for tangent. Tangent is positive in Quadrant 3, but everything else is negative. And the C in Quadrant 4 means cosine is positive in Quadrant 4, while the other two trig functions are negative. So there are actually two angles that will give you positive 1 for the tangent, and one of them is 45 degrees. Since the other positive 1 will be in tangent or in Quadrant 3, then I have to figure out what angle in Quadrant 3 has a reference angle of 45. Well, it's 180 plus 45, which is 225. Now let's go talk about B. Why did the calculator give you negative 30? Well, the calculator is going to do this interesting thing that I'll mention right now and we'll talk about again another day, which is the sine values. The calculator will always give you an answer between 90 and negative 90. This is also true for tangent. The inverse cosines will always give you an answer between 0 and 180 degrees. So now that you know what the calculator is going to output, really this is just like a reference angle. So if it's in Quadrant 4, and I want to know its coterminal angle between 0 and 360, I can just add 360 to this and find out that it's the same as 330 degrees. But there's another quadrant where the sine values are negative. If you look at your All Students Take Calculus, sines are positive in Quadrant 1 and 2, but they're negative in 3 and 4. So my two answers will be in Quadrants 3 and 4. Well, 330 is in Quadrant 4. What is going to be the angle in Quadrant 3 whose reference angle is 30 degrees? Well, it's 180 plus 30, which is 210. So the other answer is 210. So when you do inverse trig functions in order to find angles, unless otherwise stated, there will be two answers that give you that angle measurement, because there are two quadrants where your trig function is positive and two quadrants where your trig functions are negative. All right, let's talk about multiple trig functions. I want to evaluate each expression and assume that the angles are in Quadrant 1. As much as I would love to plug this into my calculator, sometimes the calculator will not give you an answer that you expect. So in order to do this, we're going to do it by hand, which is, we're going to start with inverse cosine of 4/5. This is the same thing as saying that the cosine of some angle is 4/5. We've done these problems. This is adjacent, this is hypotenuse. I'm in Quadrant 1. So here's my triangle in Quadrant 1. Here's adjacent. Here's hypotenuse. So the missing side must be 3, so it's a 3, 4, 5 triangle. Or if you use the Pythagorean theorem, you'll find out that the missing side is 3. Now I can find the tangent of theta, and the tangent is 3/4. Will the calculator have given you this answer? Yeah, probably. Where you run into a problem is if the final answer has a radical in it, because the calculator will not give you an answer with a radical. Okay, let's go do this again. I'm going to first do arc cosine 2/5. It's the same thing as inverse cosine of 2/5. That means the cosine of my angle is 2/5. Since I said it's in Quadrant 1, I'm going to draw my picture in Quadrant 1. Here's theta. adjacent, hypotenuse. And when I do the Pythagorean theorem, I'm going to get the square root of 21. Now, we're going to find the cosine of theta. Well, wait a second. Did I even need to find the square root of 21? Or, yeah, did I need to find that missing side? No, probably not, because the cosine of that angle is still 2/5. So what looks like it just happened was it seemed like these canceled each other. Well, that's what they do. Cosine and inverse cosine, they're inverses of each other. And what do inverses of each other do? They cancel. You know, like when you have like the square root of something and then you square it. Squares and square roots were inverses and they canceled. So this is a new set of inverses. All right, example 3. If G is 28 and H is 21, find angle H. Remember, in a triangle, we label the vertices with capital letters and the sides with lowercase letters. The lowercase letters are always opposite their angle, so side H is opposite angle H, and side F is opposite angle F. It usually helps to draw your picture and label your sides. All right, so if I know that side H is 21 and side G is 28, and I want to find angle theta, which I put at H, which trig function am I going to use? Well, I was given opposite and hypotenuse. The trig function that uses opposite and hypotenuse is sine. So the sine of theta is 21 over 28. So to find theta in my calculator, I'm going to do the inverse sine of 21 over 28. And the calculator is going to spit out approximately 48.6 degrees. Problem 4. Many cities place restrictions on the height and placement of skyscrapers in order to protect residents from completely shaded streets. If a 100-foot building casts an 88-foot shadow, what is the angle of elevation of the sun? We're going to start by drawing ourselves a picture of this. So here's my building, which is 100 feet tall. The shadow is going to be on the ground, 88 feet. The angle of elevation of the sun is going to be this angle. This is our angle of elevation. It goes up from the horizontal. Why is that the angle of elevation of the sun? Because the sun is going to be behind the building, which is what's causing the shadow. A lot of people think that the angle they're looking for is this one, because when I say angle of elevation of the sun, you want to pick the angle that's closest to the sun, but that's not what an angle of elevation is. So now that I have my triangle and I know what I'm finding, let's look at the two sides they gave me. This is the side opposite my angle, and this is the adjacent. The trig function that uses opposite and adjacent is tangent. So the tangent of theta is 100 over 88. So we're going to do inverse tangent of 100 over 88. And we're going to find out the angle is approximately 48.7 degrees. Don't forget to make sure that your calculator is in degree mode and not in radian mode. If you're in radian mode, you'll probably get some very strange looking answers. The last problem we're going to talk about, example 5. Solve each triangle described given the triangle below. Round to the nearest tenth. We're going to talk about a lot about solving triangles here at the end of chapter 5. To solve a triangle means to tell me all three angles and all three sides. So what I like to do is I like to make myself a chart. So let's see, what is this in alphabetical order? It's going to be J, K, L, so I'm going to start with this. In the picture, angle J is 90 degrees. They just gave me that angle K is 40 degrees. I don't know little j. I do know little k is 26, and I don't know little l. So, if I draw my picture here, and I label my sides, I like to label my sides because I think it helps when you're determining what to find first. Since you know 2 of the 3 angles inside the triangle, the easiest thing to find is the missing angle. Remember that the 3 angles inside a triangle add up to 180 degrees. So L is going to be 50 degrees. Okay, now that I know that this is 50 degrees, I can use my right triangle trigonometry to find either J or L. So, doesn't matter what I find first, I'm going to find little j first only because it's at the top of the list. So, it doesn't matter which angle I use. I can use the 40-degree angle or the 50-degree angle. I usually like to use whatever's been given. So, I was given the side opposite. I want to find the hypotenuse. Which trig function uses opposite and hypotenuse? Sine. So the sine of 40 degrees is 26 over j. When I cross multiply, I get j. I'll do this the long way. I get j times the sine of 40 equals 26. So j is going to be 26 over the sine of 40. And when I plug that in my calculator, I get approximately 40.4. All right, now you have 2 choices. Since it's a right triangle, you can find L either by doing the Pythagorean theorem or by doing another trig function. If I use another trig function, I would use instead the cosine of 40 is equal to L over, no, not cosine, let's go back. I would use, I know opposite, I want to find adjacent. I would use tangent, sorry. I would do the tangent of 40 is opposite over adjacent. This will get you the most exact answer because 40.4, that's a rounded decimal. So when you go to use the Pythagorean theorem and you round a second time, your answer gets to be a little slightly off. However, I'm not stopping you. I want you to get the right answer. So now, to find L, if you use the Pythagorean theorem or if you do this trig function, you'll find out that L is approximately 31. Now, let's do this again. I'm going to erase a little bit just to get it out of my way. Here's my triangle. Here was J, K, and L. This time, all I am given that J is 65, L is 55, and I don't know anything else. So J, K, L, little j, little k, and little l. So I start by filling out this chart with what I do know. Now, since you know 2 of the 3 sides of the right triangle, you can use the Pythagorean theorem to find the missing side. If you use the Pythagorean theorem to find the missing side, remember that j is the hypotenuse. So you would do 55 squared plus little k squared is equal to 65 squared. And you're going to find out that k is approximately 34.6. Now, we're going to have to use a trig function to find one of our missing angles. I'm going to pick angle K just because it's next on the column. So in order to find K, I'm going to use the 2 given sides. This is adjacent, and that's hypotenuse. I'm going to use the cosine of angle K is equal to 55 over 65. So K is going to be the inverse cosine of 55 over 65, which is going to give me approximately 32.2 degrees. And now that I know that that's 32.2 degrees, I don't need to use a trig function to find angle L. I can just use the fact that the 3 angles inside the triangle add up to 180. So 180 minus 90 minus 32.2 is going to give me 57.8 degrees. So we have talked about inverse trig functions for finding missing angles. We're still talking about right triangles. When you are asked to solve a triangle, solving a triangle means find all the missing sides and angles. I'm going to recommend that you create this little chart. It helps you keep your information organized, and when we move into sections 5.6, 5.7, and 5.8, it's going to help us when we're dealing with missing sides and angles of non-right triangles. And that is section 5.5 on solving right triangles.